All right, so let's move on a little bit more into this multiplication of fractions. So again, we already talked about this, but what we do is we multiply across the numerator and the denominator once in the improper, or if it's a proper fraction form. Now, if you can reduce first like we did before, that's going to be ideal as it's going to lower the work at the end and having to reduce your final fraction. So let's look at some examples. And again, we're going to first look and see if we can reduce. So will we be able to reduce anything here? It doesn't look like it. So what we're going to have to do is just take 6 times 5 and we get 30. 11 times 7, we're going to get 77. Now, can we reduce that? No, because we've already determined over here that there's nothing to be reduced, and so that would be our final answer. All right. Well, the next one kind of looks like we can probably reduce some stuff. Well, we have a negative times a negative, so that negative times that negative becomes positive, so we know our answer is positive, so that's the first thing we can do. Well, it looks like then I can take 2 out of here and I get 3, 2 out of here and I get a 4. So now it doesn't look like I can reduce anything else. And so now I can go back and say, well, okay, 3 times 11 is 33, and 5 times 4 is going to give me 20. Okay. Now, these were as improper fractions, so we're going to leave our final answer as an improper fraction. Now, what about this one? Well, we have a negative times a positive, so we know our answer is negative. Now we have a 2 times 1/3. And how does that work? Well, we might need to rewrite this as 2 over 1. So now it's a fraction. That's a fraction. So now we take numerator times numerator. 2 times 1 is 2. 1 times 3 is 3. And so we get our answer is a negative 2/3. All right, so about the next one. It looks like there's some reduction here again. We can take a negative times a negative and get positive. Looks like that 3 will go in here once, 3 will go in here 3 times, and that's going to make it simpler here. So now we'll have 17 times 1, well, that's just 17. Now we have 3 times 5, that's 15, and that would be our answer because these were improper fractions, so our final answer then would be an improper fraction as well. Now, what about division? Well, division is going to be a little bit different because we have to do a little bit more work before we can actually do this. What we have to do is we have to convert our multiplication first to we have to convert our division first to multiplication and then multiply the fractions like we've been doing. So what we do is we keep the first fraction the same. So if we look down here, we keep this the same. So let's rewrite this 2/3. Change the divide to multiply. So we change that divide to multiply. And you can put x, but sometimes x is a variable, so I'm just going to leave it as a dot. And then flip the second fraction over. Basically, take the reciprocal. So we're going to take from 5/2, flip it over. That gives us 2/5. So we keep the first, flip, and then change. Okay, and basically change it to the reciprocal. All right, and so keep, change, flip, and so now we have 2 times 2, which is 4, 3 times 5, which is 15. Okay. All right, so what about the next one here? We keep the first one the same, 10 over 9, change it to multiply, and flip it over. Well, how do you flip a -6 over? Well, guess what? That's a -6 over a 1. So now we change it. Now it becomes a -1 over 6. So that makes it a little nicer because now I can do something. Now, looks like there's a little bit we can do here. We can take 2 goes in here 3 times, 2 goes in here 5 times. We're going to keep that negative because it doesn't get canceled. And so we have 5 times a -1, so it's a -5. 9 times 3 is 27. Okay, and so that would be my solution for that one. All right, what about this one? All right, well, we're going to keep the first the same. So we'll have a -9 over 7, change to multiply, and flip the last one over. So that's 5 over 1. Well, now looking at this, there's nothing that cancels. So we're just going to take a negative 9 times 5. So it's a negative 45. 7 times 1 is 7. And then that would be my final solution to this problem. What about adding or subtracting? Well, with those, be able to add or subtract fractions, you have to have a common denominator. Okay, so looking here, it's written with common denominator. So we have the C is the common denominator. And when you take A over C plus B over C, all you do is you take A plus B all over our C. And when you do the subtraction, it's the same thing, except you subtract. You take A minus B all over C. And that's why you have to have that common denominator, because that just becomes the denominator of the addition or the subtraction. Now, if you don't have a common denominator, what you have to do is you have to get to that common denominator. And so what we need to do then is find the least common denominator, or the LCD. That's the smallest number divisible by each of the denominators of the given fraction. So what we're going to do is we're going to use prime factorization to get to this the quickest way. And we do that using a factoring tree. Okay. And so what we do is we see, okay, we have 5 over 28 plus 11 over 42. Well, 28 does not equal 42, so we don't have those two being equal here. And so the key is we're going to take 28 and we're going to take 42 and we're going to factor them using a factoring tree. Well, easiest thing to always do is take and divide by one of the prime factors first, because this is what we're doing, is we're doing prime factors. Well, 2 is a prime factor, and then that's going to go in 14. So 2 times 14 gives us 28. Well, that's stationary because it's a prime factor, so we're done there. Well, 14 we can divide by 2 again. Well, that's going to be prime. And then 2 times what is 14? Well, 2 times 7. Well, guess what? 7 is prime. So now we have the prime factors, 2 times 2 times 7 for 28. What about 42? Well, again, I'm going to divide by 2 first. And 2 goes in there 1 times, 21. Well, 21 is not prime. We can take that and divide that by 3, which is another prime factor. 3 times what is 21? Well, 3 times 7. Well, now we have, this is 2 times 3 times 7. Okay. So what will our LCD be? Well, the LCD is going to be equal to, now we look at all the terms. So we have 2's, we have 7's, and we have 3's. And we're going to use it the most time in one factorization. So if we look at the 2's, we have 2 of them here and 1 here. Well, since this one has 2, we're going to put 2 of them in our LCD. Well, then let's go ahead and look at 7. So we have 1 here, we have 1 here, so then we can take it times 7. Then what's left over? A 3. So then we'll take that times 3. So now we have 7 times 3, we know is 21. And then times 2, well, that's 42. And then times 2 more, that's going to give us 84. And so that's going to be our LCD. So now what do we do? Well, we have to convert these fractions to ones with an LCD of 84. So we have to think about that. And so we'll have 5 over 28 times what will give us that 84 in the denominator. Well, we initially had 2 times 2 times 7. Well, 2 times 2 times 7. So we have to multiply that by 3 over 3. Okay. So 5 times 3 is what? Well, that's 15. 28 times 3 had better be 84. So 3 times that's 24. That's 6 plus 2 is 84. So that looks good. Now, what about 11 over 42? Well, we're going to have to multiply by what to get that 84? Well, we're going to have to multiply by 2 over 2. So 11 times 2 is 22. So now we say, okay, well, now we have 15 over 84 plus 22 over 84. We have a common denominator, so we just take a plus b. So we're going to take 15 plus 22 over 84. Well, 15 plus 2, so that's going to be a 5 plus 2, so that's going to be equal to a 7. 1 plus 2 is a 3, and that's over 80, oops, 84. 4. Okay. Now, can we reduce that? I don't think so. That's as far as we can go on that one, I believe. And so that would be our final solution. So a little bit more work than what we've been doing up to this point, but we had to do the factoring to get our common factor here to get the LCD. And then from the LCD, we had to convert each of the original fractions to ones with that LCD, and then we could add them from there. Okay. So let's go ahead and do some more. So here we have an 8 and a 7. Well, 8 is 2 times 2 times 2, and 7, well, that's just basically a 7. Okay. So our LCD then is basically going to be 8 times 7. Well, 8 times 7 is going to give us a 56. So now we convert these. 9 over 8 times, well, we know we have to take that times 7 over 7. So that's going to be 63 over 56. And then we have a 2 over 7, and it's a negative, times what? Well, it's going to be times 8 over 8, so it's going to be a negative 16 over 56. So now what we have is 63 over 56 plus a negative 16 over 56. So that's 63 plus a negative 16 over 56. Now remember, what we're doing is we're just going to take 63 and then minus our 16. Larger minus is smaller. And if you need to, go ahead and borrow. Okay, so 6 plus what is 13? Well, 6 plus 7. And 5 minus 1 is 4. And so that gives us, the larger is positive, so it gives us 47 over 56. And that cannot be reduced, and so that would be our final solution. Okay. What about the next one? Well, this one, we have a 2 and a 7. That one's pretty easy. So 3 over 2 times 7 over 7 is going to give us 21 over 14. And 9 over 7 times 2 over 2, that's a 7. And that's going to be 18 over 14. So we have 21 over 14 plus 18 over 14. So that's 21 plus 18 all over 14. So again, when we have something simple like that, we don't have to do a factoring tree because there's no factors. Those are both prime numbers. And so now we can take, well, 8 plus 1 is 9, 1 plus 2 is 3, and that's over 14. And 3 goes in there 3 times, so there's no common factors, and so that would give us our final answer. All right, let's pause there and come back for more.